All right, a video key to go over Worksheet 5, Example 1 from Dixie Ross. The graph to the right shows the velocity v of t. So important to note that when you're looking at a velocity graph, the x-axis is going to represent rest. The particle moving along the x-axis for time 0 to 11. Note we are on a closed interval, so endpoints might be in consideration. Consists of a semicircle and 2 line segments. Use the graph and your knowledge of motion to answer the following questions. Question 1. At what time between 0 and 11 is the speed of the particle the greatest? Well, a couple different ways to think about how we could find speed. We know speed is the absolute value of velocity. So you could draw yourself the absolute value of this graph, which would leave the semicircle where it is. It would flip this triangle, near it above the x-axis to here. Or we can also say we just want the greatest velocity regardless of direction. So it's going to be a velocity of -6, which creates a speed of -6, which happens at t equals 8. The absolute value of velocity is 6, which is our maximum speed. Question 2. At which of the times t equals 2, t equals 6, or t equals 9 is the acceleration of the particle the greatest? Well, again, thinking about definition of acceleration, that's the same thing as v prime. So I want to figure out v prime of 2, I want to figure out v prime of 6, and I want to figure out v prime of 9, and then figure out which one of those is the biggest. Well, looking at my graph, v prime of 2, v prime would be the slope of the tangent line. Well, the slope of the tangent at 2 is horizontal, so v prime of 2 is equal to 0. The slope of this graph at 6 would be the slope of this tangent line, which is this linear, which looks like we go down 1, 2, 3, and over 2, so -3/2. And then the slope at 9, so over here at t equals 9, our slope is this little purple line, which looks like a slope of 3. So we would say at t equals 9, because v prime of 9 is greater than v prime of 2, which is greater than v prime of 6, was our other one. Over what time intervals is the particle moving to the left? Well, by mathematical definition, a particle moves to the left when v of t is less than 0. Looking at this graph, v of t is in negative territory between time 4 and 10. So on the interval from 4 to 10, because, explain your answer, right? Because v of t is less than 0. All right, next ones, I just cut and pasted the graph so I could have it to reference things. Over what time intervals is the speed of the particle decreasing? So speed, remember, is the absolute value of velocity. So I could draw the absolute value graph, but also if speed is decreasing, another way of saying that would be that the particle is slowing down. And we know that for the particle to be slowing down, we have to be approaching rest, which means that v of t and a of t disagree, right? They're competing with each other. So you're moving in one direction while your acceleration is going the other. So a lot of different ways you can think about this. I'm going to look at this approaching rest scenario. I approach rest between 2 and 4, and I approach rest between 8 and 10. And my reasoning would be because v of t and a of t have opposite signs. So specifically on this interval from 2 to 4, v of t is greater than 0, but a of t is less than 0. And specifically on this interval from 8 to 10, v of t is less than 0, but a of t is greater than 0. Number 5, find the total distance traveled. Total distance traveled is the antiderivative of speed, because you want to consider that all of the miles that you traveled, right? Whether you were going forward or backwards, you want credit for the entire run from t equals 0 to t equals 11. Okay? Well, the way you could do this is you could, again, draw the absolute value graph. We keep coming back to that. Maybe it would have been wise to do that at the beginning. Or we can think about how we're going to collect area. So I'm going to start by collecting this green area. That green area is a semicircle. So semi half of pi r squared. Then I'm going to find the area of this red triangle, which is going to be 1/2 base times height. My base is 6, my height is -6. But because this area implies that I was moving to the left, I want to take the absolute value of that area. I want to count that as positive area. I want credit for the part that I ran. And then finally, this little baby blue triangle is 1/2 base times height, 1/2 1 times 3. Cleaning all of this up, our total distance traveled is going to be 2 pi plus 18 plus 3/2. I'm going to leave my answer just like that because it's messy and I can. So total distance traveled is this. You could also write 2 pi plus 19.5. You could also write 2 pi plus 39/2, right? All of those things are mathematically equivalent. Number 6, find the value of the integral of v of t between 0 and 11 and explain the meaning of this integral in the context of the problem. Well, whenever we have a definite integral, 0 to 11 v of t dt, that represents the net change in the antiderivative. What's the antiderivative of velocity? You're right, it's position. So this represents the net change in the position from time 0 to time 11, also known as the displacement. Well, how do we find the definite integral between 0 and 11 of v of t? We already almost kind of did this, okay, when we found total distance traveled. That 2 pi is still going to be around. That 18 is still going to be around, except this time I need to account for the fact that I was moving left during that interval, and that 3/2 is still going to be around. So my final answer is equal to 2 pi minus 33/2, and this would mean that that's where my particle ends up at time 11. We end up 2 pi minus 33/2. This will be to the left of where we started, because 6-ish minus, why can't I do math? 16-ish is going to end up with a negative displacement, okay? But this means we're going to be to the left of where we started, which they don't give us a starting value, okay? So I think we're allowed to assume that we're starting at 0. I realize number 7 was not in here, but it is on your worksheet. Here we go. If the initial position at time 0 is equal to 2, find the position at time 11. Well, let's think about this. I know that the integral, come on, pen. All right, well, I'm trying. There we go. I know that the integral from 0 to 11 of v of t dt is equal to the net change in the position of my particle. So now let's just fill in what I know. I already did this work, this work was right here. 2 pi minus 33 halves equals, I want to know what this is, so I'm just going to leave that for a second. X of 11 is what I want to find. And then they told me that my initial position was 2. So what I'm going to do to isolate my position at 11 is add 2. So this will be 2 plus 2 pi minus 33 halves is equal to my position at time 11. Now, the other way you could think about this is that your start plus your collection of changes is equal to where you end up. So my start was 2 plus my displacement, which I found in number 6, my net change, is going to be equal to my end. Okay, and this is all just the idea of we don't have to have, as we saw in number 6, you can talk about displacement, that we were 2 pi minus 33 halves left of quote-unquote start, whatever that start is. Maybe it's your house, maybe it's a flagpole, maybe it's the lake. In number 7, they tell us, hey, what if you had started at 2? Okay, well, we're going to start at 2, and then we still have our displacement of 2 pi minus 33 halves. Next worksheet will have a new video.